All right, so when we've talked about a battery being hooked up before, so we're going to go into a little bit more about that. So a battery is a source of potential energy. Okay, a source of potential energy. Or a source of potential difference, like our volts. Okay, where's my notes? Here it is. Just as a water pump can increase the gravitational potential energy of water, a battery will increase the electrical potential energy of a charge. Electrical potential is the pushing power behind charges, pushing charges to a higher electrical potential energy. So when a potential difference is applied to a circuit, a current is created. So current is with an I, very important. It is the flow rate of electrical charge, okay? So the flow rate. So how fast the flow is going, okay? So an example, a battery is a voltage source that causes a current to flow through a MP3 player and produces the music you hear. The definition of current is also expressed as an equation. This is I is equal to Q, because it's the charge per amount of time. So find this on your data sheets. Found it? It's underneath delta V equals delta E over Q.
Yeah. So you look at this one, to the right, one down. Not this one, but this one. So you got it. No, that's totally not. Is that the
Now, I is current, and you could have it coulombs per second as the units, but we refer, like a coulomb per second is the same as saying an amp, okay? And that's more kind of the lingo we use. When we talk about current, we don't talk about coulombs per second. People will talk about amps, okay? So I'd like you to use the amp unit. So 1 coulomb per second is 1 amp. So the ampere is amps, or A is the fundamental unit of current, so that's the one that I'd like you to use. Now, when it's talking about Q is the charge, this is the total charge. So if we had like multiple electrons, we would add up the total amount of charge of those electrons. So I'll give you a little example here, so write this out with me. If 5,000 electrons passed through a point in 8.2 milliseconds, what is the current? So if I is equal to Q over T, this is total charge. I have 5,000 electrons. So I need to take the charge of an electron multiplied by 5,000 to get this one. And this is divided by, it needs to be in seconds. Right now I was told it in milliseconds. So that's a really, really, really small amount of a second, a millisecond. So I divide that by 10 to the power of 3, or times it by 10 to the power of 3, or divide by 1,000 to get seconds. To get 9.756 times 10 to the power negative 14. And we can put coulombs per second, but in my final answer, I'm gonna use amps. So 9.8 times 10 to the power of -14